Now that we've discussed the problems of the present and looked at some of the solutions from the past, it's time for us to plan for the future and take a look at where do we go from here. No matter how cute it might be, obviously we can't breed tiny horses for use inside the brewery. We do need to, however, recognize the simple and straightforward fact that the standard size of beer keg is too large for a single individual to lift safely, particularly over the course of a career. It's also time to recognize how injurious and difficult keg lifting actually is, and to take that into consideration when we're planning our brewery and bar spaces, as well as our access to lifting aids, not to mention our attitudes. We must sadly recognize that the international standard for beer distribution is unlikely to change anytime soon. Likewise, our clients' needs aren't going to change anytime soon either. However, we do have craft breweries that are embracing 30, 20, and yes, even 10-liter kegs because of the inherent lifting issues. This includes some inherent inefficiencies. There's fewer liters per keg, which means more kegs per liter, which means more wasted shipping air, more wasted surface area, which leads to greater consumption of cleaning chemicals. However, the biggest difference is going to be for the front of house because you're going to have a higher number of keg changes. However, you can daisy chain kegs together. One of the other things that we can do, even in the small brewery and in the brew pub, is we can consider our tasks and arrange our workflows such that we're not lifting the keg as often, that we consider lifting the keg to be something we are prioritizing against. So something that big breweries do is they track the number of touches. They track how many times an operator touches an individual product. And this is one of the ways they measure product handling efficiency. The greater number of times a product is touched by an operator, the more it costs you. So by reducing the number of touches, you reduce the overall cost of the product. However, this also applies to safety. The fewer times an operator interacts with a hazardous item, the fewer times we're going to have that hazard come back to haunt us. Tracking the number of touches is also something that can be done in the small brewery, and to much the same benefits. You still get financial benefits from touching the keg less because your operators have more time to do other tasks. You also get the same safety benefits. If a keg doesn't have as many times to be moved, you don't have as much time for injuries to develop because you're not doing as many lifts. Front of house cold rooms in particular are bad for repeated short interval keg moves, particularly when you have to rearrange kegs to get something closer to the tap because the hoses aren't long enough, or the hoses are tangled, or someone has inefficiently organized the keg room prior to your arrival. Aside from work attitudes and other organizational changes, architecture and interior design combine with these techniques to lead to a more efficient flow of beer through a building. You don't just want the beer to flow through the pipes and through the people, you also want it to go through the building. It's one of the ways you avoid cross streams, and it's one of the ways you handle product recalls much more efficiently as well. When we're talking about building architecture, something that's very helpful for tracking touches in workflow is something called a spaghetti diagram. It's where you draw arrows connecting where items come into a room, where they're moved through that room, and where they go out. Ideally, you have as few crossed lines as possible. Where lines cross, so do people. When people interact, when people cross, you're going to have more accidents, and you're also going to have more times when things need to be moved out of the way, or when workflows need to be briefly interrupted to accommodate other employees. You want to have as little crisscross as possible, and have more sort of straight noodles than a tangled spaghetti, hence the name of the diagram. Recognizing that a lot of brewery employees will still have to do the dangerous lifting, even perhaps knowing that they're not safe to do, we got some lifting tips from the experts for how to handle the most extreme loads that the body is supposed to handle in the workplace. You've probably heard in the past to lift with your knees. We now give a little bit different advice because lift with your knees was always a little bit vague. In particular, the curvature of the spine is part of what helps it bear loads properly. Keeping your spine curved, especially the lower spine, curved properly, helps the spurs on the back of your spine interlock to handle the heaviest loads. Put simply, the advice is to stick your bum out. You need to bend from the hips and the knees rather than from the low back, keeping your bum bent outwards. This keeps the joints in the vertebrae together, supporting the load rather than putting all the load on your intervertebral discs. We're now going to briefly touch on some of the ways we can use to determine what safe loading for an operator actually is. Safe loads in this case will refer as much to the frequency of the lifts as it will to the size and nature of the lifts themselves. Try not to be too intimidated by this slide. This is called the REBA Employee Assessment Worksheet, and it looks at all different types of movements that an operator might have to do during their day. So this one looks at not just lifting, but different types of, say, crouching, perching over, and different types of wrist movements that an employee might have to do. So this is actually a very valuable resource if you're looking at putting together a packaging line as well. At the bottom of the slide, we see some of the tools we can use to do the assessment. There's both the option of using complicated video cameras and motion capture, as well as the much cheaper method of simply using your eyes and best estimates. REBA sits somewhere in the middle. It's a little bit closer to the eyeballing side of things. The key in REBA is the rapid entire body assessment. It's there to give you a quick idea as to something that's probably okay and something that maybe needs some review. This chart here shows the different factors that affect what our safe lifting limit is. This takes into account a number of different factors, but most importantly, how many lifts you're doing in a day. The biomechanical limit is what you can do before your body starts damaging itself. Specifically, it's what you can output before you start really compressing those squishy discs, not just scarring the surface, but actually changing their shape. Note that you can execute lifts that will do this type of damage, and that's why there's multiple limits on this chart, which is why this biomechanical limit is above the physiological limit indicated by the blue arrows. The physiological limit comes from the body's plumbing, your cardiovascular system. At that point, your body simply doesn't have enough throughput to be able to actually keep up with the repeated pace of loading. So the physiological limit is very much related to how good your cardio system is and how many of these complicated lifts you can do in a day. So it's the body's ability to supply fresh oxygen and other chemicals and also remove waste products that is key to the physiological limit. The yellow arrows indicate the psychophysical limit, and this is what feels safe for you to lift. You may notice, of course, that these limits are actually quite different to each other. So our safe lifting limit that we want to apply in the workplace is the least of all these. Okay? We want to go below all of those curves, and this is indicated by the green arrows. These limits are going to be fundamentally estimates based on our best ways that we measure the human body and the human capacity to output work and the loading it can take. For low frequency lifts, these are lifts that we do very rarely. The biomechanical limit is conservative. Okay, so for rare instances where you may have to move, say, some Christmas stuff, a seasonal item up onto a high shelf, it's a very low frequency lift. So the relative risk that poses to a worker is comparatively low. The high frequency lifts are where the physiological limit is conservative. Okay, so we want to be below the physiological limit for some of those tasks that we do very, very often. The danger zone comes where our psychophysical limit, the one that we feel is safe, is above the curve of the safe zone for our lifting. Okay, so you have to be aware to stay out of the danger zone and stay in the green part of the curve. When you climb above 3 lifts per hour, you start to get into the territory where the psychophysical limit is actually a slight overestimate of what the physiological limit is. So if you have, say, a production lineup and you're doing an activity more than 3 times per hour and you're having workers coming to you saying, I think this is hurting me, they're probably telling the truth. It probably is hurting them, and in fact, you can probably scale back well below what they think is safe, because of the nature of accumulated damage. So provided we keep the size of the lift and the frequency of the lift low enough that it stays in the green zone of this chart, we're going to avoid doing the type of long-term damage that we're worried about here. Now, what this chart doesn't look at is other things that can impact the safety of a workplace. You know, if a lift is being done at the top of a tall ladder, next to moving machinery, even done with the wrong footwear, there are other things that could make an activity unsafe. However, this is looking at just our loading and how often we're doing that loading. Tables like these are used to examine how safe a high-frequency lift or action is going to be, right? So if you're doing a pull or a push every, say, 5 minutes, it'll give you a different load for if you're doing the same push or pull every 30 minutes. You don't need to memorize or be that familiar with these tables. You need to know they exist and that you might have to use them sometime. So the last slide actually examined pull type of loads, and these ones look at actual lifts and carries. These charts are maybe not the best ones to use for our keg lifting because our keg lifting is frankly well outside the bounds of most definitions of safe lifting. But there may be solutions available today to help us combat some of the awkward lifting scenarios that we see. So Dr. King was actually kind enough to let me try out one of these cool new exoskeletons that they're trying to put forward for PSWs in their awkward workplace lifts. I found this personally to be extremely helpful and very much relieving of the type of back pain I experience. This video shows me executing a fairly simple lift. The box is considered to be a slightly awkward dimension to lift, and the weight is approximately medium. However, this shows you the type of range of motion you can go through. This is a passive type of support system. There's no motor involved. There's only a spring-wound steel cable that is controlled by a clutch on your shoulder. You set your preferred working height, activate the clutch, and then the steel cable engages to transfer the load from your shoulders and upper back around the exoskeleton and down to your thighs. The human body is still outputting all the labor required to do this task. I won't lie, they're not exactly stylish. It's definitely a workplace type item. They're not that uncomfortable to wear. I didn't feel uncomfortable wearing one sitting at a desk for approximately half an hour. The smile you see on my face in the last photo there is partly because I had not bent over without my body making a popping noise in longer than I care to mention until I tried out one of these things. So if you're interested in this exact type of unit, I'm not getting paid or anything by them. It's a HeroWare brand unit, and I believe it's a startup company that's a partnership with a university in the United States. I also do apologize for the socks rather than proper shoes in this video. I had to jump on the opportunity to try this before they were shipped out from Dr. King's home, and in the course of doing that, I had to try them right away, indoors. So let's try to bring this train into the station. Let's have some final thoughts to consider. I think it's worth asking, can we do better? It's long past time that we examined our relationship with the half-barrel keg, consider how we supply draft beer, and ask that critical question, can we do better? It will be a long time before there's an affordable robot that can easily navigate a bar's back room, but some of these people assist options might be right around the corner. And always remember that protecting the employees you have is almost always cheaper than designing and purchasing a robot that you don't have. So as we leave this topic, I hope you've taken some time to consider what some of the different approaches that we can use to address these issues, namely how we move kegs in the first place, whether or not we're moving the right size of kegs, how many people we assign to the job, how much we expect them to do of that job in a given day, and notably, what some of the other solutions to this might be. And with that, I'll leave you. Thanks for watching, stay safe, and once again, a big thanks to the talented Dr. Emily King, the well-read Alan Brown, and the incomparable DJ Steele. Once again, I'm Matt Phillip. Thanks for watching.